Hey everyone! So yesterday we started talking about circles. So remember this kind of standard form for circles is x minus h quantity squared plus y minus k quantity squared equals r squared. And remember this hk, opposite of what we think there, that is the center of our circle. And then our radius is just r. So again, quick reminder, let's say I have something like this. So my center, that horizontal displacement would be positive 5. And the vertical displacement, opposite of what I think again, would be negative 6. And then my radius, the square root of that would be 10. So I have a center with a circle with a center of 5, negative 6, and a radius of 10. Again, hopefully that wasn't too hard for you yesterday. Today, though, we're going to switch things up a little bit. So today, I'm going to give you problems like this. And I want you to write it in standard form. So write it in this form where it's really easy to tell what the center and the radius are. So today, notice we have it all FOILed out. It's all multiplied out. So hopefully you guys are putting together what we've done the last couple of days together. You're putting those pieces together. And hopefully that you're coming to the realization that in order to get it into standard form, we are going to need to complete the square. We're not going to have to go through and totally solve, but we need to do the majority of the process. So first thing when we're doing this, we kind of want to make sure that our x's are together. Our y's are together. In this case, we don't have a linear term for the y's. And we want to make sure that that constant is on the other side, just kind of like what we did when we were completing the square. So x is together, y is together, and constant on the other side. The other thing you want to make sure of as well is that your leading coefficients for your x squared and your y squared, that quadratic term, is also a 1. So we'll kind of see in the next example what we're going to do when that is not a 1. All right, so let's go ahead and do this. Let's go ahead and complete the square for the x's then. So I'm going to fill in that blank because I know I'm going to have to add something. Normally, we would need to complete the square for the y's as well. But since there's no linear term, we know that it's going to end up being a 0 for that vertical displacement. All right. So now, remember to get this number that we add to both sides, what we do is we take that linear term and divide it by 2, and then we square it. And that is what we add to both sides. So 2 divided by 2 is going to give us 1. 1 squared is 1. Remember, we need to add that to both sides. Next thing we need to do is factor this. And remember, it's going to be a, how do I want to say this? It's going to be the same factor, so we can write it as something squared. So in this case, it's going to be x plus 1 quantity squared. And look at that, we're done. So my center then, keep in mind I could technically write that as this. It would be the same thing. My center then is the point -1, 0. And my radius, r squared is equal to 16, so my radius is going to give me 4. Look at that. So notice when we're completing the square, that's all the farther we needed to go. We didn't need to take the square root of both sides or anything like that. All right, let's go ahead and do one more example. So again, same directions. We want to write it in that standard form where we easily can tell what the center and the radius is. All right, so remember when we were setting this up, I said we wanted to have our x's together and our y's together. So I'm going to go ahead first thing and move that so they are next to each other. And my constant is already on the other side, so I don't need to worry about moving that over in this one. Next thing I said, remember when we're completing the square, we always want to have those leading coefficients. Those always have to be 1. So in this case, in order to make that 1, I'm going to divide both sides by 5. You remember one of our rules for completing the square was that those leading coefficients had to be 1. All right, now we are set up for completing our square. So I'm going to go ahead and rewrite this with my spaces in there. And notice I'm adding 2 things to this left-hand side, so I also have to add those same 2 things to the right-hand side as well. All right, so let's go ahead and do this. So our x's, first thing we need to do is divide that linear term by 2 and then square it. So 8 divided by 2 gives me 4. 4 squared is 16. And again, this is what's going to trip you up. This is what tripped me up. Remember, if we add it to this side, we also have to add it to that side as well. All right, let's do the same things with the y's. So I need to divide my linear term by 2 and square it. So we're going to get -3 squared, which is going to be +9. And again, remember to add it to both sides. And now let's go ahead and rewrite this in our factored form. Oops. So let's see, I can rewrite that as +4. So x plus 4 times x plus 4. Notice that number that goes in here is what your linear divided by 2 was. 8 divided by 2 is 4. That's the number that goes in here. Same thing over here. This will be -3. Again, -6 divided by 2 is -3. And if we were to copy paste that and plug that out, we'd end up right where we started. And then over here, 16 plus 9 is going to give me 25. And look at that, we're done. We are in standard form. So my center is going to be the point -4, +3. And my radius will be 5. All right, as always, please email me if you guys have questions. And don't be afraid to pop into my office hours as well. Have a good day, guys.